Okay, so we're going to go over the last portion of Section 3. Again, I break Section 3 up a little bit because, well, it gets to be a little long, and I know that you guys have games and stuff. So we try to break it up a little bit so it's not too overwhelming. Okay, so first off, we have learned how to determine molar mass. We're going to make sure that we understand the number of moles, and we're going to convert moles into representative particles. So at this point, we're going to be able to do all three. So let's look at the first part. So if we have silver acetate here, we are given the number of moles of that. So let's start from here. We're going to determine our mass and representative particles. So if we start with 2.5 moles of AgC2H3O2, we're going to convert that into grams. So now, for this, we have to find the molar mass of this. If you take silver plus 2 carbon plus 3 hydrogen plus 2 oxygen, you're going to get 167 grams of AgC2H3O2. And because we have moles here, we haven't canceled that out, so you have to put 1 mole of our silver acetate on the bottom. We've now canceled out moles. Multiply the top divided by the bottom. You get 417.5 grams of your silver acetate. 2,302. So that's how we get mass. So let's go to representative particles, because that's something we need to do too. It's easier to go from those when you're already in moles, because we already know that conversion. So you just take your 2.5 moles, because that was our given, of our silver acetate. We know that we put 1 mole on the bottom, and then we put our Avogadro's number, because remember, representative particles could be formula units, ions, atoms, molecules. Those are all representative particles. And so in this case, we're going to use Avogadro's number, 6.022 times 10 to the 23rd. Multiply the top, divide it by the bottom, and we get 1.51 times 10 to the 24th. This is a ionic compound, and so we would put formula units. Of silver. Oops, really skipped me down there. Silver acetate. Okay, so let's keep going. So the next one is going to be glucose. Now, in this case, it gives us the mass of glucose, and it wants us to go to molecules, and it wants us to go to moles. So let's start with our mass of glucose. We have 324 grams of C6H12O6. So if we convert this into representative particles first, we take this number. We're going to find the molar mass, because we have to have grams on the bottom, grams of glucose down here. And so we want to cancel that out. So we are going to find grams. So we take 12 times 6 plus 1 times 12 plus 16 times 6. We get 180 grams. That's all over 1 mole. Remember, it's grams per mole. Oops. Of glucose, C6H12O6. Well, we're not two representative particles, and in this case, it's a molecule because it's a covalent compound. So 1 mole has to go down here of our C6H12O6, and then we put Avogadro's number up here. 10 to the 23rd. Now, later on, you guys are going to find out that this mole and this mole may not always be 1. Okay, that number may change. However, this is a step when we're doing it simply and we're not converting to another atom. We need to make sure that we follow through and do. So in this case, we're going to multiply the top, divide it by the bottom. You get 1.08 times 10 to the 24th molecules of glucose. And I just wrote glucose out. So now let's go to moles of glucose. Okay, so we are going to start again with our 324 grams of glucose. And we are going to look at the molar mass of glucose. Well, that's 180 grams. Now, up top, we know this is going to be 1 mole. We don't have to do any further steps because now we are in moles already. We don't need to go any further. Our label's canceled out. And so in this case, we are going to multiply the top, divide it by the bottom, and you get 1.8 moles of glucose. Okay, so those are your answers for this. Let's do one more and then we'll put the rest as extra problems. Okay, so let's insert page break. Okay, so let's go on to our benzene. So in this case, we are given our representative particles of benzene. So you have 5.65 times 10 to the 21st. And because this is a covalent compound, it's going to be a molecule of benzene. And let's convert that into moles first. When we convert to moles, we have Avogadro's number on the bottom. We put 1 mole on top. Molecules are canceled out. Multiply the top, divide it by the bottom. And in this case, you will have 9.4 times 10 to the negative 3 moles of benzene. Okay, so let's do our molecules to grams now. So we're going to start with our 5.65 times 10 to the 21st, molecules of our benzene. We still have to put Avogadro's number on the bottom. Cross off our label of molecules. That's 1 mole of benzene on top. Goes to, we want to cancel moles out, so 1 mole of benzene goes on the bottom. And then we put the molar mass of benzene up top again. 6 times 12 plus 6 times 1, you get 78 grams of benzene. Multiply the top, divide it by the bottom. And in this case, you're going to get 0.73 grams of benzene. Remember, later on, we're going to know that these 1 moles that we have here that seem kind of pointless that we're writing in, we're going to be going to moles of different compounds from this step. And so they're not always going to be 1, but you need to know how to get there. So we can look at the extra problems to see the rest of the problems for the day.